Okay, last time we talked about what alkanes are. This time I'm going to start to talk about alkanes that have some interesting side groups that are not just hydrocarbons to them. And we call these functional groups. There's a lot of them that we can have. We're just going to deal with one type today, which is going to be alcohol. But before we get to that, let's take a look at the building blocks that could be involved in functional groups here. We've already gone over hydrogen, right? So hydrogen we know forms one bond. So it has a tinker toy, kind of looks like that. Oxygen, if you remember from your valence electrons, forms two bonds, right? So it could look like that. But it could also be a double bond, as we'll see later on. Could be like that. And another fellow that we'll see a lot is nitrogen. And nitrogen, as you remember, forms three valence bonds there. So it has a three-bond situation like a triangle. The only ones we'll deal with today in alcohols are going to be O and H, because that's what comprises the alcohol group. And it looks something like this right here, OH. Or you could write it as dash O, dash H if you want to, but I'll probably just write it like that so you know that that means alcohol. So whenever we add OH to an alkane, it becomes an alcohol. And we've done several labs this year that involve alcohols. Okay, let's go over the naming of them. Well, it's the same way as always. You find the longest chain, and then you take a look at the functional group here. So in this one here, the longest chain, simply a one-carbon chain. That's really easy. And we remember that's methane. And over here, you can see that on the methane, the functional group here is the OH. So that's an alcohol. So we would call it methanol. And if you look at it right here, that would be the condensed formula, CH3OH. And we want to write it as CH3OH. We don't want to write it as CH4O because that could be a different molecule. We want to write it so that it shows the functional group. And the functional group in this case is the alcohol, the OH. So if it's methanol, you'd write it as methyl, and then the alcohol so that we know that it is indeed an alcohol, methanol. How about this one? Now here we have a two-carbon chain, so the long chain is right here. Now that would be ethane or ethyl. This time it's also hooked up to an alcohol, so we'd write it as CH3, CH2, OH, that's ethanol. Now sometimes people put them together. You could write it as this, C2, and then H5, there's the ethyl, right? And then you could write it OH. So if we looked at that right away, we'd say, oh, I could see it's an alcohol. There's the OH. And then over here, you'd say, oh, a two-carbon addition, it must have been ethanol. So either one of these would be okay to write it. How about this one? Can you go ahead and write the formula for propanol? Well, we can go ahead and write it as we always did, right? So C3, right? H, okay? Now, normally, if it was propane, it'd be times 2. That'd be 6. Plus 2 is 8. But it's not 8 because it's not propane, it's propol. So it's 7. And then, instead of another H here, you had the OH. So that'd be propanol. Now, we can go ahead and write it as a structural formula. We could shorthand it. Remember, last time we decided, we don't need to do the hydrogens all the time, so we could do it this way, right? 1, 2, 3, and then the OH. So that would be also propanol. And I got lazy, right? I'm not filling in all the hydrogens here, but you can see that there is 1, 2, 3, 4, 5, 6, 7, if we did fill them in there. Okay, now let's get a little trickier here. How would you name this molecule here? Well, let's stick with our rules, right? Find the longest chain. So who's the longest chain here? That's easy. It's 4, right? Find the side groups. There it is. And find that functional group. There we go. Okay. Now this is obviously an alcohol, right? And it's obviously got butane or butyl here, right? So how would we number the longest chain, though? Would you start over here? 1, 2, 3, 4? No. You would start closest to the important group here. So this is the important functional group, so we'd go 1, 2, 3, 4, right? Okay? So this would be butanol, and you have a methyl coming in here at carbon 2. So here's how you write it. 2-methyl, oops, not isomethyl, 2-methyl, and then the 4-carbon chain is butanol. So if this wasn't here, it'd be butanol, but because you have it here, it's 2-butanol, 2-methyl butanol. Okay, very good. Let's go ahead and try one more. Now this one is really tricky here, but follow the rules, you know. So let's go ahead and do it. So who's the longest chain there? Well, that's easy. And where's the side groups? No. Where's the functional group? There. It's 1, 2, 3, 4, 5. This is pentane, and we got an alcohol, so it's going to be pentanol, right? But what type of pentanol is? The alcohol's not at the end, right? Now, which way we'd number it? 1, 2, 3 this way? Or should we start from the left to right? Well, I hope you said we'd start from the left to right, because then we hit it sooner. 3, 4, 5, right? So this is pentanol, right? But what type of pentanol is it? It's 2-pentanol, right? So let's go ahead and write that in there. This would be 2-pentanol, because the alcohol actually came in at the 2nd carbon. So you could have had that alcohol at the 3rd carbon. You could have had it at the 1st one, right? It's a difference on the name there. Okay, now we're all set up for our alcohol lab today. We're going to do a lab, and we're going to have 3 different alcohols, and they are going to be methanol, ethanol, and isopropanol, and I'll show you how we'll go ahead and figure that out.